Okay. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all. Okay, today we will continue with our next lecture, okay, on noise and vibration, which is lecture number 9. Okay, actually it's a additional part of a new course of the subject, which is EMM352, where we have include on the vibration measurement and vibration instrumentation and also measurement to these courses. Okay, so let's move on. Okay, so as what you have learned until now, okay, you already learned until the dynamic vibration absorber, okay, DVA, which is we use to attenuate the vibrations, okay, on the structure, which is also related to your project later on, how you can use a DVA to reduce the vibration of the unbalanced motor with a beam. Okay, okay, so okay, for this topics, okay, as an overview, we have three items, which is the first one on the vibration measurement, okay, and the next one is on the instrumentations, okay, this including the transducer, okay, and also the vibration pickup, vibration exciter, shaker, okay, as shown in this figure, and finally the astrometer. Astrometer is one type of vibration pickup to measure the vibrations. Okay, this is example of the astrometer. Okay, so for the next one is on the measurement, setting and analysis. Okay, what you can do in your measurement and also analysis, and finally a case study, which is on the grass trimmer and hand arm vibration measurement lah. This one I will provide another video so that you have a more clearer understanding on the methods of uh, vibration measurement. Okay. Okay. So for the vibration measurement, okay. First one, okay. So why we need a measurement? Okay, why we need to do a measurement? The first one is on the high demand lah, okay, or high demand and productivity, which lead to the higher operation of the machinery. Okay, as we know that in the factory or construction, we can observe that the operator heavily use, okay, the power tools, for example, for the machinery process and the construction process, so that that's produce a high vibrations that we as a human, we need to protect ourselves, okay, so that's why we need to do a measurement. And then the natural frequency and resonance of the machine lah. Okay, this is actually quite dangerous situations where it can produce a disruption to the machinery and also effect to the human health also. So for the old machinery, for example, you need to recheck it frequently, so that's uh, maybe there's some of the operational speed that have been changed due to the equipment have already old. Okay. So on the next one is on the theoretical validation. This is mostly related to research lah. Okay. Where when you study or you do your projects in simulations, so that you need to do the measurement so that you can validate your results. And finally, on the design of solution lah for the vibration problems. Okay, of course, if you have given a projects on how to reduce the vibration, okay, how to validate, so that you need to do a measurement to verify your results. Okay, so for example, to monitor operator hand arm vibration during the operations of power tools and how to solve it. Okay, this is should be done in the next video lah, where I show you on the example of how to do a measurement for the grass trimmer. Okay, and also we can also do for the others tools such as impact drill and so on. Okay, so this is a typical vibration measurement step. Okay, the first one, you of course you need a vibration machine, okay, of structure, and then a vibration transducer pickup. Okay, it's a sensor to measure the vibration, and then the signal conversion instrumentation such as the DAQ, okay, which send the signal to the computer for data record, and finally a data analysis. Okay, for the first one, if you have a structure or vibration, for example the power tools, so this will be a machinery lah. But if you don't have, then we can use a shaker to excite the vibrations. Okay, so the motion of the vibrating body is converted into a electrical signal by the vibration transducer or pickup lah. So basically, whatever the motion of the vibrations or body, that it can convert to the electrical signal by the uh, pickup lah, the sensor. Okay, so a transducer or sensor is a device that transform changes in mechanical quantities, for example the displacement, velocity, acceleration or force, into changes in electrical quantities lah. So that's the movement, okay, that we convert to the voltage or current, so that it can communicate with the signal instrumentation. Okay, so since the output signal, such as voltage or current of a transducer, is too small, okay, so basically the the transducer is itself is small, for example, uh, so that it cannot provide high voltage or direct voltage currents. So that's when it want to we if we need to read the data, so then we need like an amplifier, or we call it a signal conversion instrument, SCI here, so that it can amplify the data, the signal to the required value lah, so that the data analysis can be done later on. Okay, so the output from the signal conversion instrumentations can be present as a display lah, a display unit or computer for visual inspection lah, or recorded. Okay, for example, you have a if you experience using a MATLAB Simulink or LabVIEW, so that you have some of the front panel to view the data. Also, the last one is on the data. Okay, the data can be analyzed to determine the desired vibration characteristic lah of the machine. For example, you want to convert into FFT, okay, fast fourier transform, so that you can have a clear, more detail at what frequency it has been excited. Okay. Okay, the next one is on the instrumentations. Okay, so in this topic, we only touch three items, which is transducer or vibration pickup, okay, vibration exciter or shaker, and also the astrometer. Okay, so the transducer or vibration pickup is defined as a that can transform the item that can transform the value of physical variable into the equivalent electrical signal lah. This has been explained before. Okay, so the example of transducer, we have made of piezoelectrics, okay, electrodynamics or linear variable differential transformer lah, LVDT. And for the vibration exciter or shaker, so basically it's used to determine the dynamic characteristics of the machine and structure lah. Okay, this is example of the shaker we have. Okay, so we can have in terms of mechanical, okay, electromagnetic, electrodynamic or hydraulics shaker. And finally, this accelerometer is the most useful sensor lah in vibration measurement, because it can be mounting in contact with the structure, okay, such like velocity or displacement sensor, it need non-contact, so it's quite difficult in some situation. And for this one is the most useful lah, okay, for the vibration measurement. And the method of mounting also is necessary to be understand lah, okay. Okay, the first one is on the transducer vibration pickup. Okay, so for the piezoelectric transducer, uh, so it's a certain natural and manufactured material lah. For example, this piezoelectric, we have quartz and Rochelle salts that can generate electrical change when subject to the deformation and mechanical stress. It's a smart material basically, where when you give a force to the piezoelectric, it can generate electricity signal, while when you give the electric signal to the material, it can convert the signal towards the movement of the material itself. Okay, so the electrical charge can disappear when the mechanical loading is removed lah. So for example, you have loading here. Okay, when you give stress to the material of a piezo, this is piezo. Okay, so it can provide a voltage lah. Okay, inversely, it can, when you provide the voltage or signal to the structure, it can give a motion lah. Okay, motion. So that's why it's a smart material. So such material are called piezoelectric material, and the transducer which take this advantage of the piezoelectric are called as a piezoelectric transducer lah. This is a astrometer that basically use a piezoelectric material. Okay. Okay, the next one is on the another transducer. We call it electrodynamic transducer. Okay, so when an electrical conductor in the form of coil here, for example, okay, move in the magnetic field, okay, when we give a charge signal, so that it can produce a voltage be out here, okay, the movement. So the magnetic field can be produced either with permanent magnet here, okay, or electromagnet, and sometimes the coil is keep stationary lah, and the magnet is made of move. Okay, since the voltage output here, okay, is an electromagnetic transducer is proportional to the relative velocity. Okay, V out is proportional to Vt. Okay, so that is used basically used lah for the in terms of velocity pickups. Okay, measurement. Okay, because it can produce velocity, so that is one of the sensor that can be used. So D is a magnetic flux and L is the length of the coil lah. This is basically, I think most of you already learned this one in previous subject, or maybe electrical subject or mechatronics. Okay. Okay, so the next one is on the vibration exciter. Okay, the shaker. First, we have a mechanical exciter lah. Okay, as shown in this one, we have two types, direct or rotational unbalance. Okay, this is direct drive, and this is rotational unbalance. Okay, for the direct drive is use either the reaction exciter, okay, or the vibration shaker table lah. Okay, the mechanism is like this lah. We have a link here, A, B to C. When it move, the table can be moved in a vertical direction lah. Okay, so consists of table guide to have a rectilinear motion here. Okay, this is a rectilinear motion driven either a crank slider, okay, Scotch shock or cam type mechanism lah. Okay, this is a fully mechanical type. And the rotating unbalance is only use a reaction exciter, okay, not of a precision shaker table. These two unbalanced mass rotate in opposite direction, okay, for example here, okay, opposite direction, okay, so that it can generate a dynamic reaction force in the vertical direction lah, in this y directions. Okay, so the reaction exciter develop its exciting force through an initial loading caused by accelerating of the reaction mass lah. Is basically typical F equal to ma, where we have a reaction mass and also accelerating that can generate the force through it. So this is one of the example that been used in your project, where you want to excite the beam using this rotating unbalance motor. Okay. Okay, the next one is on the electrodynamic exciter. Okay, so this one is more towards a reverse, okay, or electrodynamic transducer. Okay, and compared to the electrodynamic transducer is a reverse concept. So we have a shaker here. Okay, this is the hydraulic shaker, electrodynamic shaker, sorry. So the voltage AC is applied to the range of frequency lah. For example, okay, you have this one, maybe we have some connected wire plus and minus. So you have a sine wave, for example, you want to excite at the voltage and time which a certain amplitude, for example 5 volts. So later on it can move as this motion lah. Okay, the vibration at this plate, above plate, can be moved as this excited motion. Okay, so you can also decide the frequency. Maybe you want to run at frequency of 1 hertz, for example, maybe up to 10 hertz. So it can be done lah, can be tuned, and it can be generated. So the current will pass through the coil, okay, this coil, and generate the force lah, okay, the force that can excite or the movement of the shaker itself. Okay. So also of course you have a magnetic flux intensity towards the coil. Okay, so you will use this equation also. Okay, uh, related to the shaker, electrodynamic shaker. Okay, so an instrumentor is a sensor that produces an electrical signal that proportional to the acceleration lah. Okay, so when we use instrumentor, it will measure the acceleration lah, meter per second square, and the and the vibration components to which acceleration is attached. Instrumentor is attached. Okay, so the acceleration of the vibration components is a measure of how quickly the velocity of the vibrating component is changing lah. Okay, so this is a you want to change velocity to accelerations, so of course dB per dt, the changes of the how quickly the velocity change toward the vibration lah, so that you can measure the acceleration in terms of unit. Okay, so the acceleration spectrum can be derived from the waveform from the time domain, for example here, mean by the calculation mathematics to the frequency domain. So this is, for example, you have a motor here. Okay, you run a motor, for example, at 22,000 RPM. So you attach your accelerometer here. Okay. So the accelerometer, you can get the signal lah in terms of time domain. What is the amplitude, meter per second square, okay, in terms of time, and then you convert to FFT so that you can get clearly at what frequency. For example, this one maybe at 2 hertz have the highest speed lah. Okay, maybe higher speed maybe at 10 meter per second square. So it also has another harmonic speed lah. For example, this one at 4 at 6 hertz. So from this you can have a more clearly understanding at what frequency you want to countermeasure it. Okay. Okay, so the next one is on the mounting of accelerometer. Okay, it's important for you to understand also the method of mounting your accelerometer. Okay, so the way the accelerometer is mounted is very much determines the accuracy of the result collected lah. Okay, so mount it as close as possible to the components. For example, if you have a bearing, especially close to the center line of the bearing to avoid pickup of the distorted signal. So for example, you have this motor. Okay, this is the center bearing here. So you must mount it at a center line here lah. So this is the wrong one. Okay, where it is off center. Okay. Uh, Okay, so that's some of the method lah. Okay, so okay, this is another type which is you know the exact location of the bearing here, so that you can mount directly at the upper side of the bearing. Okay, instead of you mount it at the far away like this, so that it will not give a more the accurate signal lah. Okay, so make sure the accelerometer is firmly attached. Okay, so you have here, you can see this is firmly attached and also this is firmly attached. This is not uh, the way that we want to mount lah. So basically mounting by the magnet is more popular lah if the surface is steel, made of steel. So basically we have some kind of, this is magnet lah, we call it magnet, so that it can mount it firmly lah. Okay, which offer a balance between the measurement reliability and convenience of the user. Okay, so also make sure the accelerometer is oriented correctly lah. Okay, because you have the accelerometer above and below sides, so make sure you mount it properly lah, using the correct surface. Okay. Okay, the next one is on the measurement setting and analysis. Okay, this one is I will explain in more detail in the next video. Okay, on the demonstration. That's why you can observe clearly what kind of equipment that we use. But this is typically a step that you need to go through before you get the data lah. Okay, the first one is on the measurement parameter setup. Okay, during this stage you need a sensor calibration lah. Okay, so if you use accelerometer, okay, you need to calibrate it, because we need to check whether the accelerometer is functioning well or not. Okay, so basically the calibrator have a one fixed it's like a shaker, a small shaker that give a fixed frequency and also fixed amplitude. So if you put the sensor on the calibrator, and the sensor can give a output signal, for example, at 10 hertz, which amplitude of 10 meter per second square. So that's you know that your sensor is function well lah. Okay, that's the important thing before you do a measurement. But when you put the sensor, it give like 5 hertz and maybe 5 meter second square, it's not correct to the what the calibrator means. So you need to change your sensor lah. Okay. So you also need a data input, okay, the channel setup, or how many sensor that you want to use, maybe 3, 4. So that's important lah. You need to set up each of them. Okay, type of data to be measured. Okay, what kind of data you need, such as time domain, frequency. Okay, also the sampling rate is also important lah. The more higher sampling rate, the more accurate you get lah. Okay. Okay, so the data records is into a quality of data to be record. Okay, you can use this setting lah, like if you want to use a average amplitude. Okay, maybe you maybe you need a peak one, the peak value, okay, the RMS, root mean square. Okay, maybe, or you need a average value lah, that depend on what kind of data you need to record. And also the filtering type windowing, you can see here, when we apply the handing windowing, the data is more clean, okay, compared to no window use. This is some kind of filtering lah. Okay, if you can get this data, is better. Okay, so finally the data display and analysis, what kind of graph. Okay, this is related to this one lah. Okay, term of time, frequency domain. Okay, the unit of amplitude here you can change. Okay, maybe you measure in acceleration, you can convert to velocity and displacement later. And also the data extraction lah to external software. Maybe you want to use the data, you want to convert to Excel for more further analysis of the data lah. Okay. Okay. Okay, so comes to our last slide. Okay, this is the case study that I produced another video for you to have a more clear understanding the method of instrumentation, how to mount the instrumentor, and how to measure data and so on lah. So for this case study, we use a grass streamer and hand arm vibration measurement. So we have a list of equipment lah. This petrograph streamer here. Okay, 3 instrumentor that we mounted at the shaft, one at the handle, and also at the hand lah, operator hand. And calibrator, this is the calibrator that I mean before. Okay, the like a small shaker. And the EQ system, we have this one, the SCI, the conversion system, the software, and also the laptop here lah. Okay, so you will have another video to get more understanding on this. Okay, so thank you very much.